Hey everyone, welcome back, and we are going to be using Origami Studio to make a scroll wheel interface today, which I think is pretty neat, and you could use that for a whole bunch of different things. All right, let's get into it. All right, let's start out with a brief overview of what we have in this video today. So I'm going to give you a little bit of more of an overview of what this is and just the surface level of how this works. Just so if you want to skip over the details of it, you can just grab the components and start applying it to different things. The second section is going to be on a deeper dive of how it actually does work and some problems that I had to encounter and fix to make this usable for yourselves as well. So this is probably like 75% of the video because there's a lot of detail in here, but I think it would be interesting if you are trying to get better at origami in general. You'll probably learn some things from just how that breaks down. But of course, the entire file will be provided to you so you can just dissect it as well. And then lastly, we have two variants of how that is actually being used. And frankly, they're really dang simple once you have the correct output from the core patchwork. We're going to go through a very classic example of a progress bar being moved with a scroll wheel, which is, harkening back to the iPod as the original use case for something like that with the click wheel. And then we're also going to go through the timer interface, which is shown really on the prototype itself, where you have an infinite kind of style wheel, but you still have that fidelity of control that a scroll wheel provides. So yeah, this is going to be the entire video, and with a big chunk that you can probably skip over if you like. All right, let's get back into the overview. All right, overview. So one thing I want to point out is I have bolted on a progress bar just because it's a bit easier to demo that, but these are completely separate things really. So there's the timer, and then I just also connected the interaction to a separate kind of output so you could experiment with that as well. I might actually leave that up, even though it looks completely ridiculous, but it can help communicate some ideas of how this is working as well. All right, so the tricky thing with a scroll wheel interface is, let me pop this up too. This layer represents the interaction area that we're allowing users to use so it can capture the input. So if I'm clicking outside here, there's nothing, but if I'm clicking in here, that is capturing as appropriate. But this is not exactly straightforward because what we're trying to do is capture the speed at which someone is moving around in a circle. And when you think of what you have in default in origami is you have X and Y coordinates, and that doesn't map exactly. So you can go like up and down and left to right. Like that stuff is easy to capture and parse, but you don't have that by default. So you need to find a way to create that. The result of that, in the end, is all the way to the right here. And let me just zoom out actually to see a full scope of this file. This here is the main thing. The rest is kind of just, some of it is purely cosmetic. Some of that is just some other implementation. The real body of this is this long stretch here, which goes from, this is an interaction patch for this red square there. And on the far right, I've highlighted, is a patch variable of rotational velocity. That's what we're trying to get to. And once you have that, you can do a whole ton of stuff with that. However, really tricky to actually make that happen. Okay, this is going to be the breakpoint. So you want to skip ahead, you'll just start to see how you can use that rotational velocity in a couple different ways. But otherwise, we're going to get into how this actually works. So, as mentioned in the overview, we have XY coordinates. So how do we change that up? If we want rotational velocity, we want the speed at which someone is going through this. X and Y isn't enough. The best way to visualize this is probably a clock, the hands of a clock. We want the speed at which a hand is going around the clock. So the rotational angle and then the speed of that thing going around. So how do we get there? We have a couple things that are going to help. Full disclosure, this first half of this entire sequence I found in online somewhere, and I can't remember where I got that from. I'm sorry, I will try and find that and put that in the description as well. And then there's a second half that I added onto this to resolve some incomplete parts of this to make this fully function. Anyways, back to the core of how this does work. The key here is, let's talk about first how this breaks down. So I put together some diagrams to explain this better. The hit area that we were looking at before, the nice thing about that is it creates a new kind of coordinate zone. So you're not using like the screen coordinates of like 0, 0 being the middle. 0, 0 is now the patch center here, or the layer center rather. So positive X values are over to the right and positive Y values are below, and vice versa for the negative versions of that. So that's the raw material that we're working with. Now, the nice thing about origami is that there is a patch called arctangent. So arctangent, I'm just going to pop this open in the library right now so you can see the description of it. Arctangent calculates the angle of a triangle given its x and y dimensions. Which, if we go back to that diagram, if you're providing xy coordinates, let's say you're providing coordinates that are like over here, it tells you the angle of that line, because that would form a triangle, which is exactly what we need. That's how we're going to get the angle going around this entire thing. And if you do plug values into this, you can see that, let me just do with this right here, spin that around. You can see that this is the degrees value that is changing each time. So I also have a diagram for that to make this a little bit clearer. If you're over to the right, that's about 0. If you start going clockwise, you start approaching 90, you pass 90, and you approach 180 degrees. If you go the opposite direction, counterclockwise, you'd go negative 90, approaching negative 180 degrees. But here you can see that there's a potential problem because 180 and negative 180 are essentially on the same spot. So you're crossing a threshold, which gets a little weird. Let me show you how that actually creates problems within here. This second half of work that I put together is to overcome this problem, but I can just bypass that so you can see the result of not having a solution for that. So I have the simple velocity of this going across, and more accurate, like the full rotation of it. And as it approaches this side where the 180 issue is, look at what happens. It jumps wildly. Well, not necessarily wildly. It's actually going back a full rotation in either direction. So you can see that's happening because this progress bar is connected to that same output, and so is a timer. So they're both being affected by this. And if we look at the actual numbers here, this is the raw rotation. You can see that as I go up to that point where it's around 340, cross that threshold, and it did a minus 360 on it. Go in the other direction, pops that back. So this is an issue because we are trying to calculate velocity, and velocity, let's look at how Origami defines that by pulling up the velocity patch. Measures the speed a value is changing, takes the value from the current frame and subtracts the value from the previous frame, and that difference is going to be the velocity. Which makes sense. That is going to work for most of this wheel's rotation. Because in most cases, that's probably around, and the raw velocity number is right here. It's around 1, let's say, depending on your speed. You can go beyond that, but let's say it's averaging 1 just for simplicity's sake. But that velocity ends up actually being, for one frame, 360, which is a huge, huge spike, which is causing those numbers to go awry. So we have to solve that. But to back up, let's just show you a little bit more of how this is working. So in that gesture, it is grabbing the XY coordinates of where you're actually interacting with, and with reference of this middle being the 0, 0, 0 rather. Unpacking it, throwing it into arctangent, you get the angle. There's some accumulation and like feedback loops there of how to best describe this. As soon as you start interacting, it pulses to sample and hold. It needs the initial spot, or initial angle rather, of where you dragged, and then it starts tracking your current position. So it knows if you're going clockwise or counterclockwise, essentially. So that's what a lot of the rest of this is, FYI. And eventually we have an accumulation. This raw rotation is an accumulation, or it's supposed to be an accumulation of the distance of rotation that you've gone in angles. So if I just keep turning that, you can see that's going up but that's generally supposed to be about 360 for a rotation. Except you can see that it demonstrates here the this kind of snapback issue that we were just talking about. So this was tricky, but this is how I've tried to resolve this so we can have a nice smooth value by the end. I'm going to plug this back in, this compensated velocity. So I'm using the wrong velocity, or the velocity that demonstrates the problem, to help fix it as well. So this raw rotation is having the velocity be calculated, and we know that the velocity is going to get a weird spike going from an average of like 1, 2, or 3 to 300 plus. So we feed that into two logic controls, So if it's either above 300 or below negative 300, that's probably when it's going over the threshold. So if you want to be really specific about this, this should be like if it's equal to 360, because that's in theory what it's going to do, but it's just not that precise. Like you can go really quickly and it just might be jumping over that frame. But I found just from experimentation that these thresholds work pretty well for capturing this instance, which is what you can see if you might be seeing a brief flash of the check mark. But the outcome of that is also over here. So each time one of these is met, it is essentially minus 360 or plus 360 to the accumulated rotation value. So if I just spin this around and you look at these two numbers here, you can see those popping up because it's adjusting the value. And so unlike the raw rotation, which had some finicky behavior as you were crossing this threshold, if you look over here, you'll see that it is actually behaving as intended at this point. There's no visible glitch with the numbers counting up or downwards. It is just proceeding as we'd like. And that is also being fed into a new velocity calculation and giving us the rotation velocity that you can actually use in a whole bunch of different ways. And that's that. Once you have that, most of this is implementation agnostic. So once you download this, if you want to just select all of these and put these into a component and make sure that you publish the rotational velocity and the gesture rotation, it's the two things that I would publish, and the input of the gesture as well, so you can change what layer is being referenced for interaction coordinates, then you don't have to think about it again, because that can be reapplied in a whole bunch of different ways that will be fun to experiment with. So that is how this works, but it's probably going to be easier once you see it in action. So let's get into how that works. The first thing that we're going to look at, let me hit the reset button here, is the classic use case of a progress bar for, let's say that is a song in progress. It is super simple from a layer standpoint, exactly how any progress bar would be built. You have the background element, which is just a static rectangle, and you have a progress fill, which is a rectangle that is being sized horizontally, anchor point on the left side. That's all it is. And here, the patchwork is also really, really simple. Here's the rotational velocity that we derived from the work below. And here's a sensitivity adjustment that I'm just going to move out of the way because it's not necessary. It's just a tweak, and it'll make it seem simpler. So we have the velocity feeding into an accumulator pattern, which if you've done the gyroscope tutorial, it was a big part of that. It was also just part of the work below. I'm realizing it's used all over the place. It's slightly different though from how you might have seen it previously, because in this case, I'm using a clip patch for that. So I'll just show you quickly the clip patch notes here. It gives you a min and max clipping amount, which in this case is useful because I don't want the progress going below 0 or above 342, which is the max width of this thing. But it accomplishes the accumulation process as well. And then it just feeds in the width. That's really all it is. And you can see here, without the sensitivity, it's a little just too quick for my liking, which is why I put a sensitivity patch in here, which is just a multiply at 25.25 rather. And that's it. Now you have pretty fine controls when you're moving slowly, but you can also just really whip it around and go pretty quickly, which is the great thing about having a scroll wheel interaction. And that's the whole thing. I just took that velocity and plugged it into a new set of patches and bolted on this progress bar onto this prototype. Pretty easy. Okay, let's look at the timer now. I'm just going to hide this for simplicity's sake. So the timer is working similarly with a bunch of just a couple extras. Here is the timer area, and this is this group patches is the core functionality of it. Let's zoom in a bit more. Here's the rotational velocity feeding through a sensitivity adjustment, just like the progress bar. And that is feeding into this patch, which is just an addition patch with a couple different inputs. And I've labeled this counter traffic. So as a general pattern, when in origami you need to have a couple different things affect a single value, you often end up with this kind of pattern where this patch is coordinating traffic. You have a bunch of different inputs. They have different conditions to whether they are applying anything to it, which means by default, I often have these at 0, so they don't do anything. And then for a single frame, they might flash a different value in there. But otherwise, that is feeding outwards through a clip into a counter variable. And this is also creating another accumulation pattern because the counter is also in here feeding back into itself. These bottom two ones are optional. These are very specific to this implementation. This third one is a decrement tick. So if I just hit the start button here, you'll see that is flashing -1 as a pulse every 1 second. And that's how this decrements. The fourth one is a reset pulse. So this is constantly storing the exact value of the current value of the counter times -1. And then if I hit this button, it just flashes that value into this addition patch as well, which effectively zeroes it out, which is the most complicated way that you can say x equals 0. But in this kind of sequence, that's just how it goes. Yeah, it's pretty dang simple, the core functionality of this thing. The rest of it is fairly cosmetic. Over here, I've separated out how this is showing the actual string. So the counter value is being rounded to a nice round number, is being formatted in date time, and then that spits out the actual number you see above there. There's also branched over here where every time the whole rounded value changes, it plays a little bit of haptic feedback. So that's going to feel in coordination with the speed that you're going, which is really nice. And I was really trying to get through the Apple Watch crown kind of feeling, because that has a nice real fine-grained haptic feedback to it. You're not going to get quite the same stuff on the phone. It doesn't have that same responsiveness, but it's still approximated. It's still pretty cool. And below here, we have the adjusted rotation, which is why I did separate that out below here into its own variable, even though that's not being used down here, is being pulled out so it can then affect the rotation of these assets, which if you're going to do a more classic scroll wheel that doesn't have any physical movement on it, just disconnect those. It's still working. That's why this is a cosmetic kind of thing. But for this demo, I think it adds a little bit of visual interest to this and makes it a little bit easier to understand as well, having something that is moving in the right kind of rate with the raw data, let's say. Yeah, that's how it goes. The rest of this, and just for clarity, is really simple state management for buttons and the timer stuff. Like, let me just start and stop that. You'll see a bunch of things flashing. This thing is being recessed in and out of the backing with a shadow creeping upwards. There's nothing fancy going on here. It is just it's just a volume of patches, and it's done in a very suboptimal way, kind of messy, because I didn't really want to think twice about it. So the main core of this stuff is actually really, really simple once you get past all of this, which you can, again, completely ignore. Okay. That's it. That's the entire tutorial of how to create or use a scroll wheel prototype interface in Origami Studio. I hope you all find that useful. Feel free to just, again, grab that patch, put it into your library, never really think about it, but please play around with it, experiment with it. I would love to hear or see anything that y'all make with it, because I've just scratched the surface. I went to like the most basic ideas I could, but I'm hoping to use that more in the future. And yeah, this is one of the tutorials of my series. Got one more left in the bag that I'll get started on soon, but if you've been following, thanks a lot. Please like, again, subscribe. I'm going to keep making videos on a regular basis on this channel, and I appreciate all the support so far on this channel. It's been super nice to hear from people and know that it is helping some people too. So I'll cut it there. Thank you so much for watching, and see you around. Bye.